All right, welcome everyone. This is the last section of our Unit 1. It deals with toxins. So we'll be answering questions like, what is toxicology? How do toxins affect us? What are the different types of toxins? And how do they relate to the environment? So first we need to define what is toxicology. Toxicology is the study of toxins or poisons and their effects, particularly on living systems. Because many substances are known to be poisonous to life, toxicology is a broad field, drawing from the different disciplines of biochemistry, histology, pharmacology, and pathology. Toxins damage or kill living organisms because they react with cellular components to disrupt metabolic functions. Environmental toxicology, also known as ecotoxicology, specifically deals with the interactions, transformation, fate, and effects of natural and synthetic chemicals in the biosphere. This includes individual organisms, populations, and whole ecosystems. Aquatic toxicology focuses on the sediment water, water organism, and water air interfaces, while terrestrial toxicology focuses on the effects of metals on soil, fauna, community, and population characteristics. So we'll be combining all three of these different types of toxicology in this course. How do toxins affect us? Well, toxins have something called allergens, which are substances that activate the immune system. Some allergens can act as antigens, that is, they are recognized as foreign by white blood cells and stimulate the production of specific antibodies. Formaldehyde is a great example of a widely used chemical that is a powerful sensitizer of the immune system. It is directly allergenic and can also trigger reactions to other substances. Widely used in plastics, wood, products, insulation, glue, and fabrics, formaldehyde concentrations in indoor air can be thousands of times higher than in normal outdoor air. The EPA, the Environmental Protection Agency, estimates that poor indoor air quality may cost the U.S. around $60 billion a year. And this is from people not showing up to work, right? Absenteeism or reduced productivity. All linked to toxins, believe it or not. The immune system depressants are pollutants that suppress the immune system rather than activate it. Immune system failure is thought to have played a key role in the widespread deaths of seals in the North Atlantic and even dolphins in the Mediterranean. These dead animals generally contain high levels of pesticides residues, polychlorinated biphenyls, say that 5 times fast, or also known as PCBs, and other contaminants that are expected of damaging the immune system and making it susceptible to a variety of opportunistic infections. Okay, so that's what's going on here. And this dude's like, no, stay out, right? Chilling. Okay, awesome. This is an example of a polychlorinated, right? We've got our chlorine, okay? And that's an example of an endocrine disruptor. These are chemicals that disrupt normal hormone functions. Some of the worst, right, are the persistent chemicals such as BPA, right, dioxins or PCBs, and these interfere with normal growth, development, and the psychology, how our body functions, of a variety of animals, including us, right? And normally at very low doses. Often these chemicals can cause sexual dysfunction, right? And that's either reproductive health problems in males or certain feminization of males, right? These are sometimes called estrogens or androgens. They all affect other hormones as well. Some researchers suggest that the endocrine disruptors may be contributing to our obesity crisis. Wouldn't that be wild if it was a toxin that we were releasing that is messing with our metabolism or something along those lines? All right. Another type of toxin, right? We had endocrine disruptors. Okay, we also had allergens, right? Another type of toxin is called a neurotoxin, and they're a special class of metabolic poisons that specifically attack nerve cells or neurons. The nervous system is so important in regulating body activities that disruption of its activities is especially fast acting and devastating. Heavy metals such as lead or mercury kill nerve cells and cause permanent neurological damage. Anesthetics such as chloroform, ether, and chlorinated hydrocarbons, right? Like this one, this is a chlorinated hydrocarbon, like DDT or aldrin, okay? These chlorinated hydrocarbons disrupt nerve cell membranes necessary for nerve action. Organophosphates and carbamates, I think I'm saying that correctly, inhibit, oh boy, acetylcholine. I have no idea. I'll have to look that one up. I apologize. But basically, it ends in A's, so that means it's an enzyme, right? So these different types of chemicals or toxins, they interfere with the enzyme that regulates sort of transmissions to be received and generated between nerve cells. Okay, neurotoxins, right? Some examples and how they actually function. How do neurotoxins debilitate you? How do they poison you, right? Another type of toxin is a mutagen, okay? And they are agents such as chemicals or radiation. They are agents that damage or alter the DNA, the genetic material in cells. This can lead to both birth defects and or tumor growth. If damage occurs in the reproductive cells, the results can be passed to future generations. It is generally accepted that there is no safe threshold for exposure to mutagens, as any exposure has some possibility for causing damage. So an example of a mutagen, right, something that might alter your DNA would be like exposure to like radiation, right? Another example of like a chemical could be like if you're a smoker, right, you're more prone to cancer, right? That would be a chemical ingesting chemicals, right, into your lungs, okay, and that can cause this is cancer. It looks like, right? That's the idea. Mutagen is another type of toxin. Carcinogens. So maybe I got ahead of myself. Carcinogens are substances that cause cancer, invasive, out of control cell growth that results in malignant tumors. Okay, so this is uncontrolled cell growth. Cancer rates rose in most industrialized countries during the 20th century. Now, cancer is the second leading cause of death in the United States. 1 in 2 males, okay, and 1 in 3 females will have some form of cancer in their lives. That blew my mind. That is crazy. I feel like the numbers have just skyrocketed, right? And that's because of these carcinogens that either we're putting in the atmosphere or we're putting into our waters or maybe even directly putting into our body. So how do toxins move? Well, we can think of the movement, distribution, and fate of toxins as both individuals, right, and as sort of an ecosystem compartments, right, between these chemicals. We can think of both individuals and as an ecosystem as sets of interacting compartments with which chemicals move. Based on molecular size, I see an essay question, solubility, stability, and reactivity, right? Based on those 4 things, they are going to move, distribute, and sort of travel, right? Travel in different ways. The dose, route of entry, timing of exposure, and sensitivity of the organism all play important roles in determining toxicity, right? And so I've got a couple pictures of wetlands because they actually form as a function of they will trap toxins and sort of filter them out in a way as well. They will filter the water that has toxins in them. So the movement or the fate of these toxins, right, rely a lot on the solubility, right, to determine where and when the chemicals move. These chemicals, the toxins, can be divided into 2 major groups: those that readily dissolve in water and those that readily dissolve in oil. Water-soluble components move more rapidly and widely throughout the environment because water is ubiquitous and aqueous solutions bathe all our cells. However, molecules that are oil or fat soluble generally need a carrier to move through the environment. Okay, and that might be an example of our bodies, right? That would be an example of an oil way that an oil soluble toxin could enter us. These molecules get stored within our bodies and are more likely to be, vocabulary word, bioaccumulated in fat stores where they may be protected from metabolic breakdown and persist for many years. So what this last sentence is saying is that some of these oil-based toxins or fat-based toxins we are ingesting by choice, or maybe not by choice, maybe by lack of knowledge of, right? And they accumulate in our bodies because they are protected from metabolic breakdown. Okay, so this idea of bioaccumulation, right? So the exposure and susceptibility of each individual human, right, determines how we will respond. Because we breathe far more air every day than we consume a volume of food or drink water, or the amount of water we drink, airborne toxins are generally more of a cause of ill health than any other exposure. The tissues in our lungs are very efficient at gas exchange and both toxin absorption. The largest exposures for many toxins are found in industrial settings, right? Where workers may encounter some doses thousands of times higher than would be found anywhere else. And that may result in something like this, right? Certain genetic abnormalities. A condition of the organism and timing of exposure also have strong influences on toxicity. Healthy adults, for example, may be relatively insensitive to doses that would have been very dangerous for young children. Okay, and that the same goes with people that are already weakened by a certain disease. Exposure to a toxin may be very dangerous at certain stages of developmental or metabolic cycles. Okay, but it also may be dormant or innocuous at times. A single dose of teratogen thalidomide, which is a certain chemical, right, taken in the third week of pregnancy, which I might add is a time in which many women aren't aware they're pregnant. This toxin can cause severe abnormalities. Okay, and this is in fetal limb development. That's what we got going on here. There's all sorts of crazy toes. Okay, exposure to toxins. This is real life, guys. And so bioaccumulation and another vocabulary word, biomagnification, they both increase the concentrations of chemicals inside of certain organisms' body. Bioaccumulation is the selective absorption and storage of a great variety of molecules. Toxins that are rather dilute in the environment can reach dangerous levels inside cells and tissues through the process known as bioaccumulation. Right? And so if I eat a lot of cookies that have toxins in them, and the cookies are only tiny, but I eat a bunch of cookies, they stay inside of me, right? They accumulate inside of me. Okay, biomagnification is a little bit different. That occurs when the toxin burden of a large organism, okay? Basically, you're consuming lots of small order trophic levels, okay, and it's accumulated by a predator. So I've got three examples here, and they're all from sort of marine ecosystems because that's where I'm most comfortable. But you could think of like as a bear, I guess could be biomagnification. But if a tuna, right, eats a fish that has some sort of toxin in it, and the fish has eaten another fish, and that fish has eaten the plankton, okay, the idea that these toxins that are very small in doses can actually start to accumulate, right, and they become magnified in certain organisms. And then at that point, it's bad news for those big organisms, right? Awesome. This is a diagram that sort of shows you the shows you the different trophic levels and the accumulation of the toxins. So we have the producers down here, which have a low concentration of toxins, right? But they are consumed by the consumers, and our concentration of, this is our toxin we're looking at here, is DDT. So our concentration of DDT is increasing as we go up the trophic level, and it's not only doubling, it's an exponential increase, right? Phytoplankton and bacteria in aquatic ecosystems take up heavy metals or toxic organic molecules from water or sediments. Their predators collect and retain the toxins from prey organisms, building up higher concentrations of toxins. Some materials, okay, degrade quickly so that their concentrations decline quickly after release. However, depending on the persistence or how easily the chemical or the substance break down, right? If it breaks down very easily, it's not much of a threat. But if it takes a long time to break down, it presumes a much greater threat, right? Most modern herbicides and pesticides, for instance, quickly lose their toxicity. Okay, they don't persist very long in the environment. They're broken down. Other substances persist for years. Okay, and so I've got a picture of styrofoam, and it actually looks like they found some sort of larvae that is able to convert the styrofoam into energy. That is awesome, right? Other substances like metals or lead or PVC plastics, and asbestos, they are valuable because they are resistant to degradation. So they're good for using for maybe building supplies, right? But they're not very great for the environment because they last so long. Lead attacks the nervous system both in adults and in children, causing decreased mental ability, kidney damage, anemia, miscarriages, and fertility losses. Manufacturers of lead-containing products disputed evidence of harm, and so they stopped allowing for lead sinkers, right, in the ocean because they realized that lead was actually not great for the organisms at all. Perchlorate, which is this guy, this compound, actually it's an ion, it's an anion. Perchlorate is a waterborne contaminant left over from propellants and rocket fuels. Ooh, yummy. These are commonly found in over 12,000 sites in the United States where military has tested live ammunition. An example of that is Plum Tree, right, which is right across the bay. This polluted water is then used to irrigate crops such as alfalfa and lettuce, and that's introduced to the human food chain, right? Either via milk, the cow eats alfalfa, we drink milk, we get the contaminate from the alfalfa, which was in water initially, right? Human and cow milk samples detected perchlorate in nearly every sample across the United States. This chemical can interfere with iodine uptake in the thyroid gland, disrupting adult metabolism and childhood development. Okay, and so there's this awesome video. Every one of us, if not hundreds, have these persistent toxins in our body, right? We acquire them from the air, mostly from the water that we drink, from the things that we eat, and even the surroundings, right? The things that we touch. We don't know how dangerous these are, but it's a cause for concern. And so there's this, I encourage you to watch this video. It's talking about glyphosate, which is the active ingredient. Oh no. Next up we have Tony Mitra. How do I get rid of this? Oh no, go back. I'm having all sorts of technical problems. No. Okay. He's talking about how Roundup was the active ingredient in Roundup is glyphosate.
Hundreds and hundreds of enzymes, proteins, vitamins that we need, that we get from our food, is not automatically taken from the fruit. It needs to be broken down into its elements and rebuilt up into the exact molecule.
Anyway, this guy provides a great perspective on sort of Monsanto, which is the big company that has essentially a monopoly on agriculture, right? The fertilizers that they're placing on it, the herbicides like Roundup or the insecticides that they're putting on it, that's eventually being incorporated into our water, and it's getting in our bodies, and we don't know the effects, right? So that's why we need people like you guys to study it, right? Metabolic degradation and excretion eliminate toxins. In the background, I've got a picture of a harmful algal bloom. They release a toxin in the environment. And so most organisms have enzymes that process waste products and environmental poisons to reduce their toxicity. In mammals, most of these enzymes are located in our liver. Right? Alcohol is a form of a toxin. It runs through our liver, and we're able to filter some of those toxins out. Sometimes, however, these reactions work to our disadvantage. Wah, wah. Compounds such as benzopyrene that are not a toxin in their original form are processed by these same enzymes into cancer-causing carcinogens. Okay, and so that's a great example of something that's not initially a toxin, but it is transformed into a toxin within our body. We can also, reduce the effects of waste products and environmental toxins by eliminating them from our body through excretion. Primarily, excretion is a function of the kidneys, which can eliminate significant amounts of soluble materials through urine formation. Accumulation of toxins in urine can damage the kidneys and bladder. All right, I think we're almost done. There are a few repair mechanisms which help mend the damage found with toxins, right? Tissues and organs that are exposed regularly to physical wear and tear or toxin or hazardous materials often have mechanisms to repair that damage. These organs have high cellular reproduction rates to replace injured cells, right? So we have a cell that dies off because of a toxin, and it's able to reproduce faster than other types of cells. In each reproductive cycle, however, there's still a chance that some of the cells will lose normal controls, running amok, creating a tumor. Tissues with high cell replacement rates are among the most likely to develop cancers. Sorry for that. Cool. So your review questions. So for your homework, you just have to answer these two review questions. What is biomagnification and why is it important in environmental health? Number two, how do the physical and chemical characteristics of materials affect their movement, persistence, distribution, and fate in the environment? I hope you guys had a little fun, or you were a little entertained and you learned something today. Until next time, peace and love. I will see you guys later.